Hi, welcome to Tech. So today we are looking at arrays, specifically single or one-dimensional arrays, and so we are going to work with this project so as to understand further. So the question is, write a C++ program that calculates the determinant of a 3x3 matrix. So I have given you everything you will need. This is how the matrix looks like. This is how you're breaking it down, and this is what we're calculating to find the determinant. This means determinant of A, and this is how we will find the determinant. So this A is here, then EI, which has been broken down this way, is what you're going to be using to calculate. If you want to familiarize yourself, you can just look at matrices before you start on this. So then I also have given you an example of a 3x3 matrix, and I have calculated it and found my answer to be -306. And so this is good for you to use as a test case, such that when you run your program the first time, you can use these values and see if the answer is this, so as to confirm that your program is working as we need it to work. Yeah, so let's get started. We're going to be focusing on arrays, and we're going to use also at least one instance, that is, we are going to use the ternary operators. So you're going to see how it works if you're not familiar with it. I have already created my file, and so you can do the same. I am using code blocks as always. And so let's get started. First of all, we need to get the input from the user, and that you're going to use an array. Okay, so we start with arrays right away. So let's first start by, of course, you're going to do C in, C out. So #include IOStream, that we need, and then we go to our int main. Then inside our int main, okay, I would like us to display to the user the same way I have just displayed here, so that the user also knows the order in which the data should be entered. Yeah, so let me just go to that real quick. We start with that. Then we can end line. Let me just do it twice so that it makes it spaced out. And then now let's start displaying how the user should enter their data. Then let's tell the user what that is all about. Again, I'm using the new line characters to just make it spaced out. Then now, how are we going to be able to put, how is the data going to be taken in? First character you enter will be A, then B, integer, sorry, then C, then D, then E, F, G, H, and lastly I. Okay, then let's have our new line character there, and we close. Okay, now till there, let me save, then let's see. Okay, so you see, we have the flow of matrix, then we have that, and then we're showing how the input format will be or should be. So we need to input data to our system, right? And that we're going to do using an array, because we want to input and store this data, then use it later on. And it's not just one, it's a number, and in our case it's 9, because these are 9 values here. And so these 9 values are going to be entered in, and first of all they will be integers, either positive or negative. The name of our array will be matrix, and we need to say the size. Every array must have a size, and you should define it before you start using the array. Okay, so the size of our array is 9, so that means it will hold 9 values. Okay, that's that. And then we can now start inputting the data. So we've already defined and declared our array. Now let's now start. Remember, arrays only hold data of the same type. So if I say int, that means everything stored here will be an integer. If I say string, everything will be a string. But in our case, everything is an integer. Then I want to mention something called, let me first write. So we have the size, which we're going to be using. But first, I need to mention how this works. So in C++, when we declare an integer as a variable, it gets 4 bytes of memory. Okay, and so in this case, we've declared 9 integer variables, and therefore that means they will get 9 times 4 space allocated to them. That's why if I do, for example, since we want to get the size, right, we're going to be using the length of the matrix. So when I get the size of matrix, typically it will be just 9 because we want that size. And so let me just output it so that you see what we get when we just get the size of the matrix. Okay, let me just end line. Okay, and run. So when I get 36, which is 9, okay, all the 9 slots, and then times the size of each integer, because it's memory allocation. So if I store integer 1, it will be stored from, let's say, 0 to 3. Then the next integer from 4 to the plus 4. And so in the case that we want to get the size meaning 9, the 9, not the 36, which counts plus the storage location ish wise, then we will have to divide this by the size of 1, okay, by the size of 1 integer, such that it's 9 we want, right? So 36 is the total storage, and then let's divide with 1 integer or with 1 element, so that it's not necessarily that it will be an integer. So let's say if it's another value, like let's say long, which will have 8 bytes, then it will be divided by the size of that, of the first value, and then whatever we get, that is the size of the matrix. So in our case, we are dividing it by size of the first value in our matrix. Size of our first value will be matrix. How do we access elements? Using the bracket, okay, square brackets, and then we say 0. In an array, the first element is 0, then the second element is 1, third is 2. So when you say matrix 1, it gets the second element and not the first. Arrays start from 0, indexing starts from 0. So let's run this again, and now we should get 9. Yeah, so now we get 9 because we have divided by the size of 1 element in the array. And since it's an integer which has 4 bytes, then it's 36, which is the size of the matrix, divide by 4, which gives us 9. Yeah, so now once that we've understood that, let's proceed to our input. How do we get inputs? So we're going to use a for loop to get our data. So I talked about for loops in a previous tutorial, so please look at that if you have any problems here. I actually did nested for loops, which I will not look at right now, but you can just check that out. So for int I is equal to 0, okay, so we've initialized this, and then I is less than matrix size. What do? We add, we continue adding, and then we want to be getting data while this happens. So we can have a variable that just gets data, and then this data is stored in the array. Now I am doing this, I am initializing this variable with 0 because in the previous tutorial we encountered an error whereby if you're in a function and you just say, for example, that, then interval, yes, it may be initialized to 0, but at the same time it may fail to be initialized to 0 and be given the value that was there previously. Remember, a variable just is a storage location, and therefore that storage location may have had something previously. Okay, and so in this case, if a storage location had something previously, it's better that we initialize it to 0 such that it just works as we want rather than we get errors ahead. Yeah, so we initialize it to 0, and then let's now get the data. And then we store it in the matrix. How do we do that? Let's say matrix, then call this value I, because we're going to be moving from I, which is 0, and remember we said the first storage location is 0, to I is less than max size. That means the highest number, so which is 8. Therefore our storage locations will be I, and I will be 0, then I will be incremented to 1, then to 2, to 3, till to 8. Okay, so matrix I is equal to val. Now we're giving it the value that has been entered. Okay, that's nice. Then now let's proceed. So this is, let me just do this comment and tell you what I'm doing. So this is getting input from user and storing it in the array. Okay, then we proceed. Let's now see the data that we've just input. So output data present in array. This should be output. Okay, let me just save. Now how do we output? So we're going to use a for loop again. Loops are very important. Int, we do the same thing actually. Int I, remember this I is only here, it's only used here, so it's okay if I redeclare it in this other loop. Int I is equal to 0, I again less than matrix size, of course, and we want to increase this by 1 every single time. Now in this we can just do this std cout, and then we output the value of the matrix, but I would like if it were arranged in the way a matrix looks like, because it's like it's kind of more appealing to the eye if we do that. So instead of having another loop that will be getting the first 3, then go to the next line, another 3, go to the next line, I can just use an if statement or a ternary operator. Now if I were using an if statement, I would say first I can have an integer x, which I will be I will be increasing by 1. Let me just use that because incrementing is just hard. This is the value I'll be increasing by 1 every single time in this loop, and then I'll say if x is equal to 3, I want to go to the next line. Okay, no, if x is equals to 3, I don't want to go to the next line. I want to reset x to 0 such that, okay, let me just write it first. So if x is equals to 3, I want to reset x to 0 because I want it to be looping thrice, go to the next line. Then I use another if statement. If x is equal to 0, I want it to do what? Go to the next line now. And we will use the end line. Okay, so we have these two, but this can just be replaced by a ternary operator, which works this way. First, you say the expression. The expression in our case is x is equal to 3. Then you have your question mark. Then if x is equal to 3, what do we do? Say what we do there. So I want x to be equal to 0. Else, okay, that's just how it works actually. That's just it. X is equals to if x is equals to 3, the first statement, if it's true, tell us what to do. Then if it's false, in our case we have nothing to do, so I'm just saying, just say false because I have nothing to do there. Okay, and it will work just the same as that statement that I'm just about to delete. Yeah, so then we'll just remain with this way. Then let me just take this back. Yeah, so one last thing, we have to make x plus plus, because x is not increasing right now, so it will never be equal to 3. So we need to add plus 1. Every single time we go around the loop, we add plus 1. Then it will be made to 0 when it's 3. And then again we add. Now this will allow us to go to the next line and therefore give the impression of a matrix, or rather how a matrix would look like. So if I run it, let's try again. Okay, now we do the inputs. 4, 5, 6, 7, 8, 9. Okay, so this is how it looks like. Now it looks like a matrix rather than I would just print it out this way, right? So that's the effort or the impact we were looking for. Now let's proceed to, we've printed it out. Allow me to paste that instead of writing it all over again. This explains the flow. Okay, 0, 1, 2, 3, 4. So when we want to access any of these elements, that's how we access them. The index, we place it here. So index 0 in our case, the one I've just deleted, would be 6. Okay, and it goes increasing depending on where you are. So for it to be easier, since instead of just writing all this int determinant matrix is equal to, now you know I would have to write matrix 0, right? Then in brackets, okay, multiply by, in brackets, matrix E, which is E, A, B, C, D, E, 4. So I feel like this is too tiring, and so I decided to use variables. So I named them int A, B, C, D till I, such that they replicate this diagram, and so I will just use this to do my calculation. Let's just do that. Let me just show you. So int A is equal to matrix 0. Then int, okay, instead of writing them all, let me just copy this and paste it. 1, 2, 3, 4, 5, 6, 7, 8. And then this will be B, C, D, E, F, G, H, I. Then we have 0, 1, 2, 3, 4, 5, 6, 7, 7, and 8. Okay, so I've just represented the matrices with the integers A, B, C, D, E, F, G, H, I, so that it will be easy for me to reference them. Now, then we get here int determinant matrix is equal to A times E times I minus F times H minus B times D times I minus F times G plus C, then multiply by into brackets D times H minus E times G, and then we close that. So you could just replace them. Where there is A, replace it. Where there is that, replace it. But I just preferred it looking this way. I know I have actually killed the purpose of using the matrix in the first place up there, but the concept has still been explained. How you can use matrices, how you can access them, and right now we've actually just assigned it to a variable, so we've used it multiple ways. But it could also work if you can do it. If you can, or if you want to, you can just use the matrices here instead. Okay, and it will work fine and well. Remember, matrices can be used to store data of, let's say, 50, 100, 1,000. So this will not work in that case. This only works because we only have 8, 9 values. But if we had more, then it would not work. It will not be possible to do this. It will be too tiring and kill the purpose of having the matrix in the first place. So then now let's just output our determinant, and yeah, we call it a day. So let's output it. std cout run. Any errors? No errors. We're going to use the values that I had mentioned in this so that we can confirm that the answers given are right. This, okay? Now let's go back. Six, 1, 1, 4, -2, 5, 2, 8, 7. Okay, A is equal to all this. Okay, so there is something not working appropriately. Let's check it out. Okay, this should be minus. Okay, that's just a basic simple error. Okay, I think that should be it. Now let's run it again. 6, 1, 1, 4, -2, 5, 2, 8, 7. Okay, now the answer is -306, and the answer here -306. And so that's it for today. See you on the next one. If you've not watched the previous ones, please do so, because they are very informative. I believe that to be true. And so let me see you on the next one. If you have any questions or comments, please leave them in the comment section. Yeah, goodbye.